Hi, this is lesson 1.4 in geometry, and in this lesson we're going to be talking about angles. But before we do that, we're just going to take a few minutes to review some of the vocabulary words that we've learned from these first few lessons. The first question says, name 3 points that are collinear. Now, collinear, remember the word line is in the middle. That means points that are on the same line. And we're going to look at this figure right here. And the points B, D, and A are all in a line, and we know that because there's a line drawn through there. And so I will write points B, D, and A. And remember, when we name points, we use capital letters. The next question, letter B, says name 4 coplanar points. Well, you almost have the word plane there. But that means points that are on the same plane, and there needs to be 4. And when we talk about coplanar points, we don't necessarily want to use points that are on a line. So on plane P, there's a capital P there, so that's plane P. We could say the point C and D and A and E. Or we could say point C, B, A, and E, any 4 points. Or if we're looking at plane R, let me use another color here, we could say points G, F, A, and B. Those are all on this gray plane or plane R. The next question says, what is the intersection of plane P and plane R? All right, so plane P is this one, plane R is this one, and where they intersect is all along this line right here. Sorry, my board is just not cooperating today. So this would be a line or a line segment. Theoretically, remember, a plane goes forever in all directions. So even though we just have a segment, this line goes forever because the planes extend forever in all directions. So I'm going to put line BA, or you could call this line BD or line AB, any combination of 2 of the letters, and the letters are capitalized. And notice it's a line, it goes forever, so I put arrows on the end. The next one says, name a point that lies on both plane P and plane R. Well, the points that are on both planes would be any of these points, B or D or A. So you could answer any of those points. Points, I'll put B, D, and A. Those are the correct, those are on both planes. And letter E says, name plane P in 2 more ways. This should say in 2 more ways. So plane P is this one. And remember, the other way that we can name a plane is to use 3 letters. So, or 3 letters that are at a vertex or at a point. So plane C, D, E, or we could say plane B, C, A. Just any 3 letters that are on plane P. We would not want to say plane BDA, because that would not necessarily mean plane P, because BDA also has plane F going through it. So we definitely have to pick points that are not on a line when we name the plane. Now let's look at the next figure. It says, what word would describe points Q, R, and S? Well, Q, R, and S are all on a line, so they would be called collinear. Next one says, how could you name the line above? Well, it's a line, so we would use a little line symbol, and we just choose 2 of the points. So we could call this line QR, we could call this line QS or SQ, or we could call this RS or SR, so any combination of 2 of the points. Next, it says list all of the line segments in the figure above. So a line segment, remember, has 2 endpoints. So from Q to R, so we have segment QR, that's a segment. Segment RS, And then we also would have the whole segment, segment QS. And again, if there's endpoints, we don't put the arrows for the symbol. And lastly, how would you describe the points including and to the left of point R? So starting at point R and to the left. Well, that is a ray. And so how would we describe it or how would we name it? It's a ray. And remember, we always name a ray with the initial point. So it starts at point R and it shoots through point Q. So we would call that ray Q. All right, good review. Let's go ahead and look at lesson 1.4. So today we're talking about angles. By definition, we would say that an angle is formed by two rays. So remember, a ray is a point, and all the points going to one direction. So two rays with the same endpoint or initial point, basically. So here's a ray, starts at point B, shoots through A. Here's another ray, starts at point B, and it shoots through C. Okay, so an angle is formed by two rays that have the same endpoint or initial point, depends on the textbook that you use. The rays are called the sides of the angle. So this is a side, and this is a side. The end point, or this initial point of the rays, this is called the vertex. Now, there are certain ways that we name an angle, and it depends on your situation. So in this problem, when we have just one angle, or in this angle, you could call this angle B. You can name it by the vertex if it's just a single angle. The other thing is you can name it by the three letters, angle A, B, C, and we use this little angle mark, or start with angle C and call it, or point C and call it angle CBA. The other thing you can do if there's a number, that's probably the easiest, is you can say that this is angle 1. So just remember, when you use the three letters, the vertex, which is B, is always in the center of the name. Now, you can use the one letter, the name of the vertex, if there's just one angle. But if we look right here, if we were to say angle E, you wouldn't know for sure which angle you're talking about, because in this figure, you have the large angle right here, which is angle NES, or you could say angle SEN. You also have this angle right here, angle NEU, or angle UN, and I'm going to mark it like this. Or you have this one right here, this smaller one. So there are actually three angles in this picture, angle SEU or angle UES. And I'll mark that. This has one little mark and this shows two little marks, and they're not the same size, so I don't use the same. I don't use one tick mark for each. I have to use a different number of tick marks. So when there are multiple angles, you need to use three letters to describe which angle you are referring to. So in this first example, it says give three names for the angle. Well, this is just a single angle, so you could say angle M. Or you can use the three letters. Starting here from K, it goes to the vertex to P. So angle K, M, P. Or you could start at P and go the other direction, angle P, M, K. Next, it says name three different angles. Well, we've got the large angle, so angle Q to T to S, angle QTS, or you could say angle STQ. The order doesn't matter as long as the T is in the center, the vertex. And then we have this angle, angle QTR. And lastly, we have angle RTS. Okay. All right, how do you measure an angle? Well, a protractor is a tool used to measure angles in degrees. And to measure an angle, let me see if I can get this to cooperate with me, this One doesn't always work the best, but we put this point right here on the vertex of the angle. And then we want to have this line where the 0 is lined up with the one side of the angle. And this is starting at 0 and measuring up. So 0, 10, 20, 30. So this would be from 0 to, so it would be about 38 degrees is what I'd say. So that is a protractor. It's what we use to measure an angle. Now some special types of angles. An angle that has a measurement of between 0 and 90 is called an acute angle. An angle that has a measure of 90 degrees is called a right angle. An angle has a measure between 90 and 180, so greater than 90, less than 180, is called obtuse. And an angle that has a measure of 180 degrees, so the initial side is here, goes all the way around, and if you measure it as 180 degrees, that is called a straight angle. So think of that as a straight line, a straight angle. All right, next we're going to do a few problems here. It says, give another name for the angle in the diagram. Tell whether the angle appears to be acute, obtuse, right, or straight. So the first thing you want to do is identify the angle. Angle JKN. So from J to K to N. Well, it appears to be a right angle. Now, we would never say that it is a right angle unless we actually measured it and saw that it was 90 degrees. Okay, it appears to be a right angle. And I shouldn't have done that. My board is not working well enough today, so hopefully it'll cooperate here as I'm erasing things. Next, it says angle KMN. So from starting at K, going to M, and then to N. So the vertex of that is M. That is a straight angle. Next, we have angle PQM. So from P to Q to M. Well, that looks like a right angle again. It appears to be. That doesn't mean it is. Next, we have angle JML. So from J to M to L, that's acute. So from J to M to L. So that's less than 90. So that's an acute angle. Then we'll go to the next one, angle QPN. Let me change colors. We have a lot of colors going on. From Q to P to N, again, that's less than 90. So that looks like a right angle. And then lastly, angle PLK. So from P to L to K. So L is the vertex, and that is greater than 90, so that would be obtuse. All right, we're going to move ahead to the angle addition postulate. That says if P is in the interior of angle RST, then the measurement of angle RST, so RST is this whole angle. Okay, RST is the whole angle. That measure is equal to the sum of the measures of angle RSP, which is this one right here, and the measure of PST. So this kind of goes back to, you add the two parts together and it gives you the whole. That's called the angle addition postulate. And let's do some problems with that. So in this problem, it says the measure of angle DBC is 42. So DBC. So what you always want to do is mark your diagrams. So that's 42. The measure of angle DBA is 18. So from D to B to A is 18. What is the measure of angle ABC? So 42 plus 18 would be 60. So the whole thing then, the sum of the two is 60 degrees, and I should be writing degrees here. Next one, the measure of angle DBC is 65. So again, my points didn't show up here. From D to B to C This is 65, label it, and then angle ABC. Now this one's a little bit different. A to B to C. So that's the whole thing is 85. And it says, what is the measure of angle ABD? ABD, that's this one right here. Well, basically, if we're using the angle addition, we know that the whole angle, so let me write this down, the measure of angle ABC is equal to the sum of the two smaller angles, angle ABD plus the measure of angle DBC. And so we can fill in what we know. The whole angle is 85, and then the measure of angle ABD, we don't know. I'm just going to call this X. Plus the measure of angle DBC is 65, and how would you solve that using algebra? So X equals 20. And hopefully you can look at this picture and not even need to write all of this out and know that 65 plus what number gives you 85? You'd have to subtract. So 85 minus 65 would give you 20. So you get 20 degrees. All right, let's look at this next one. It says if the measure of angle RQT equals 155, what are the measures of angle RQS and TQS? Well, RQ, this is supposed to be a Q here, RQS and TQS, they give us some measurements, but there's an X there. So we need to find the value of X, which means we need to set up an equation. What do we know? We know that the measurement of angle RQT is 155. So the whole thing, the whole kit and caboodle, I like to say, is equal to 155. And using the angle addition postulate, we know that the two smaller parts, this part plus this part, equals the whole thing. So the whole is 155, and that will equal angle RQS, which is 4x minus 20. That's the measure of this one, plus the measure of this one, which is 3x plus 14. So the two smaller angles, add those together. There's one, add those together, it equals the whole. Now to solve this, we'll combine like terms. So we have 7x minus 6, and then solve the equation. So we'll get the x by itself, so we'll add 6 to both sides. And then to solve for x, we'll divide. So x equals, let's see, 23, I believe, if I did that right in my head. And then we have to look at the question again. What are the measures of angle RQS and TQS? So what you would have to do then is substitute the value back in. So 4 times 23 minus 20, and 3 times 23 plus 14. So 4 times 23 minus 20 should give you 72. And 3 times 23 plus 14 should give you 83. And then just double check. 83 plus 72, it equals 155. So RQS is 72 degrees, and the measure of angle TQS is 83 degrees. And notice, folks, that when we're talking about a measurement of an angle, we put a little m in front when it's asking for measurement. The next problem says angle DEF is a straight angle. What are the measures of angle DEC and the measure of angle CEF? Now here's the deal. In geometry, remember I said we have to know vocabulary. So in order to do this problem, you would have to know what is the definition of a straight angle. Well, remember, it means it's 180 degrees. So if you add from here to here, plus from here to here, okay, so this angle plus this angle, it would equal 180 degrees. So let's add angle CEF, 2x plus 10, plus angle CED, this one here, that's 11x minus 12. Write those down. And what should they equal? Altogether 180 degrees because it's a straight angle. And now you'll solve this. So combine like terms. 2x and 11x is 13x. 10 minus 12 is a negative 2. And that equals 180. and then divide by 13. And we get 14. X equals 14. And then to find the angles, then we have to substitute back in. So 2 times 14 plus 10 would be 28, plus 10 is 38. And then here we have 11 times 14 minus 12. So that's 154 minus 12. And that's 142. And again, 142 plus 38, that equals 180. All right, one more here. Find x and find the measures of the angles given that angle EBA is congruent to angle DBC. Now, remember, congruent means they have the same measures. So the first thing we have to do here to find x, because we have 3 angles here where we're given some information, is identify angle EBA. So from E to B to A, that's this angle. And angle DBC, that's this angle. And when they're congruent, I'm going to put one little tick mark for each of them. That tells me that they're the same size. So we have an x going on, which means we have to think about, all right, what does it mean if they're congruent? Well, then we would say they're equal. So we can set the 2 angles equal to each other. So 13x minus 2 equals 12x plus 3. And then we solve the equation. Get your x's on the same side. So we have 1x minus 2 equals 3. And then isolate the variable. So x is equal to 5. All right, and that is it for this lesson. So go ahead and do your assignment and let me know if you have questions. Thanks for watching today.